Chapter 2. Switch functionality. Refer to the following sections to configure and use these features. 2-1. Catalyst switch families. Gives a brief summary of the Cisco Catalyst switch platforms, their capabilities, and the operating systems that are supported. 2-2. Switch campus network designs. Presents a quick reference checklist of guidelines and ideas you can use when designing your switched enterprise network. Catalyst switch families. The family of Catalyst switches is an ever-expanding product offering. One of the major challenges in choosing and deploying a switch in your network is understanding what functions that switch performs and how it functions within the network design. The purpose of this section is to give you a brief overview of the current Catalyst switch platforms and their basic functionalities. Catalyst 2000 series. The Catalyst 2000 series switches provide end-user access ports for the wiring closet. The switches are available in several models, such as the Catalyst 2940, 2960, and 2975. These access switches vary in port densities from 8 ports to 48 ports. The Catalyst 2940 series switch supports 8 10-100 interfaces along with several uplink options: 10.100, 1000 UTP, 100 base, FX, and 1000 base, XSFP. The Catalyst 2960 series switch supports 8, 24, and 48 10-100 interfaces and 24 or 48 port 10.100, 1000 interfaces, in addition to a variety of dual-purpose uplinks interfaces. The Catalyst 2975 series switch supports 48 10-100, 1000 interfaces along with 4 SFP 1000 base X uplink interfaces. The Catalyst 2000 product families offer a wide variety of Cisco IOS feature sets, such as Layer 2 Plus forwarding, enhanced integrated security, quality of service QoS, and power over Ethernet PoE. Here is the performance for the Catalyst 29XX series switches. Catalyst 2940:3.6 Gbps maximum forwarding bandwidth, 2.7 Mbps wire speed forwarding rate based on 64-byte packets. Catalyst 2960 16 gigabits per second switching fabric. Cisco Catalyst 2960-8TC S. Catalyst 2960-24S. Catalyst 2960-24TC S. Catalyst 2960-48TT S. and Catalyst 2960-48TCS. Forwarding rate based on 64-byte packets. Cisco Catalyst 2960-8TC S. 2.7 Mbps. Cisco Catalyst 2960-24 S. 3.6 Mbps. Cisco Catalyst 2960-24TC S. 6.5 Mbps. Cisco Catalyst 2960-48TT S. 10.1 Mbps. Catalyst 2960-48TCS 10.1 Mbps. Catalyst 2975 32 gigabits per second switching fabric. 38.7 Mbps forwarding rate based on 64-byte packets. Catalyst 3000 series. The Catalyst 3000 series switches provide end-user access ports for the wiring closet. The switches are available in several models, such as the Catalyst 3560, 3560E, 3750, 3750E, and 3100. The Catalyst 3000 series is a midline switch that can offer Layer 2 services or both Layer 2 and Layer 3 services in the same device, depending on the software. The switch comes in different port densities and offers fast Ethernet, Gigabit Ethernet, and 10 gigabit Ethernet support. This switch series has ports that can be directly configured as Layer 3 interfaces, or it can use VLAN interfaces for Layer 3 switching. It also supports Layer 2 functionalities on a port-by-port basis for basic Layer 2 connectivity and enhanced features such as trunking, channeling, QoS classification, and marking, in addition to access control for Layer 2 or Layer 3 ports. The Cisco Blade Switch 3100 series are used in the data center access integrated into Blade chassis. The Catalyst 3100, 3750, and 3750E offer hardware stacking, high levels of resiliency, automation, and single point of management. With Cisco Stackwise technology, customers can create a single 64 gigabits per second switching unit with up to 9 switches. Here is the performance for the Catalyst 3 XXX series switches. Catalyst 3560 E-Performance. Switching fabric 128 gigabits per second. Forwarding rate 3560E 24TD 65.5 Mbps. 3560E 24PD 65.5 Mbps. 3560E 48TD 101.2 Mbps. 3560E 48PD 101.2 Mbps. 3560E 48PD F 101.2 Mbps. 3560E 12D90 Mbps. 560E 12SD 47.6 Mbps. Catalyst 3750 E-Performance. 160 gigabits per second switching fabric capacity. Stack forwarding rate of 95 Mbps for 64 byte packets. Forwarding rate 3750 E 24TD 65. 5 Mbps 3750 e 24 PD 65.5 Mbps 3750 e 48 TD 101.2 Mbps 3750 e 48 PD 101.2 Mbps 3750 e 48 PDF 101.2 Mbps. Because of its flexibility, the 3000 series makes an excellent switch in small to mid-size campus environments and can be deployed as an access switch or a distribution switch. The 3000 series can run either the IP base image for Layer 2 switching or the IP services software image for Layer 2 and 3 switching. The IP base image supports basic routing such as RIP, static, and EIGRP stub routing. Catalyst 4500 series. The Catalyst 4500 series switch is a midline switch that can act as a high port density access, switch, and distribution switch and a low-density core device. The 4500 series is also a modular switch that offers both Layer 2 and Layer 3 services. This switch offers fast Ethernet, Gigabit Ethernet, and 10 Gigabit Ethernet connectivity. The Catalyst 4500 series offers a wide variety of supervisor engines, Supervisor 2, 4, V, and 6. The Supervisor 4, V, and 6 for the 4500 series have an integrated Layer 3 switching capability. These switches also perform Layer 2 trunking functions and provide support for EtherChannel, QoS, and PoE. The Catalyst 4500 also offers a fixed form factor switch, which is based on the chassis Supervisor forwarding engine V and 6. The Catalyst 4948 is based on the Supervisor V and the Catalyst 4900M and is based on the Supervisor 6 forwarding engine. The Catalyst 4948 offers 48 ports of 10.100, 1000, and 2x2 10 gigabit Ethernet uplinks. The 4900M offers 8 fixed wire speed 10 gigabit Ethernet ports and 2 half slots that you can fill with any combination of the following. Please remember that only the 8-port 10 gigabit Ethernet expansion module supports the Cisco Twin Gig converter, 20-port wire speed 10.100, 1000RJ, 45 half card, 8-port 2:1 10 gigabit Ethernet X, 2 half card Cisco Twin Gig converter module compatible, 4-port wire speed 10 gigabit Ethernet half card. The Catalyst 4500 also has a 7-slot and a 10-slot chassis that allows for redundant supervisor modules. Here is the performance for the Catalyst 45XX supervisor module switches. Supervisor 6 E320, Gbps 250 Mbps. Supervisor V 10 GE, 136 gigabits per second 102 Mbps. Supervisor V 96 gigabits per second 72 Mbps. Supervisor 4 64 gigabits per second 48 Mbps. Supervisor 2 plus 10 GE 108 gigabits per second 81 Mbps. Supervisor 2 plus 64 Gbps 48 Mbps. Supervisor 2 plus TS 64 gigabits per second 48 Mbps. Catalyst 6500 The Catalyst 6500 series switch is the flagship of the Catalyst product lines. It is the most robust, has the highest backplane support, and is the most flexible of any of the Catalyst products. This modular switch can act as a high port density access switch, as a Layer 2 or Layer 3 distribution switch, and as a wire speed Layer 2 or Layer 3 core switch. In addition to its high-speed Ethernet switching capabilities, it offers a variety of cards to support advanced features such as voice services, content switching, intrusion detection, network analysis, optical services, 10 gigabit Ethernet, firewall support, and encryption services. All these features function at wire speeds. In addition to these services, the 6500 chassis supports connectivity for the Fabric Module CF256, crossbar CF720 to interconnect the cards rather than the 32 classic GBPS bus. With this Fabric module, a 6500 each chassis fully populated with Fabric-enabled cards has a total of 720 gigabits per second of Fabric connectivity. The switch also offers support for redundancy and high availability features. The Catalyst 6500 series switches continue to evolve as new products provide more flexibility and functionality. For example, Cisco introduced Virtual Switching System VSS on the Catalyst 6500 with the announcement of the Supervisor 720-10G PFC3C. This allows for two Cisco Catalyst 6500 series switches with this supervisor engine to pool together into a VSS 1440. The two switches connect with 10 GB links called Virtual Switch Links VSL. When a VSS 1440 is created, it acts as a single virtual Catalyst switch. The Catalyst 6500 chassis was classified as end of sale and was replaced with the Catalyst 6500 e-chassis. The e-chassis supports all existing line cards, but was enhanced to provide a better power bus for PO and power supplies. The e-chassis also provides the following benefits from a non-e-chassis: support for 80 gigabits per second per slot, increased cooling capacity per slot to accommodate high-performance line cards, and adds a redundant control channel to improve high availability capabilities of the switch. 2-2. Switch campus network designs. When you design a switch network, you must consider many things. Adding to or redesigning a large enterprise or campus network can seem complex or overwhelming. An accepted, organized approach to switch network design can simplify the design process and make the network more efficient and scalable. This section is organized as a quick reference checklist of guidelines, rules of thumb, and ideas to help you think through the overall network architecture and configuration. Many of the checklist items include a reference to the appropriate sections of this book that deal with the switch features. 1. Segment LANs into the smallest collision domains possible by using LAN switches. 2. Organize your enterprise network into a hierarchical structure. A network designed around a layered structure gives the foundation for predictable behavior, consistent latency from anywhere in the network, and scalability. If the network needs to be expanded, you can add more switch blocks into the existing structure. The basic network hierarchy divided into 3 distinct layers. Access layer consists of switches that connect to the end users. Distribution layer consists of switches that aggregate traffic from the access layer. Core layer consists of switches that aggregate traffic from the distribution layers. Tip: in small to medium-sized enterprise networks, the distribution layer can be omitted. The access layer switches uplink directly into the core layer, which is referred to as a collapsed core design. To provide high availability, each switch in a network layer needs to have dual or redundant uplinks to 2 switches in the next higher layer. If a link failure or the failure of an entire switch occurs, the extra uplink can be quickly used. The uplink failover is handled by the spanning tree protocol STP at layer 2 or by routing protocols at layer 3. 3. Place switching functionality at each layer of the hierarchy. Access switches at this layer generally have a high port density, lower cost, features that address user access or security, and several high-speed uplink ports. Usually, layer 2 switching is sufficient, although layer 3 switching can provide higher availability for applications such as IP telephony. Distribution Distribution switches have a port density consisting of high-speed ports and offer higher switching performance, ideally at layer 3. Core. 4. Identify resources in your network that serve common functions. These become the modules or building blocks of your network design. The core layer should be built from the highest performance switches in the network, aggregating traffic from the distribution switches. Layer 2 switches can be used effectively, although switching at layer 3 adds higher availability and enhanced QoS. Usually a dual switch core layer is sufficient to support an entire enterprise. Some examples of these blocks and how they fit within the network hierarchy. Modular approach to a campus network design consider high availability or redundancy features that can be used in each network building block. Tip the network with single uplinks to higher layers for simplicity. In a real network, you need to always add dual redundant uplinks to 2 switches in the next higher network layer for the highest network availability. In this case, each access layer switch would have 2 uplinks to the 2 nearest distribution switches. In addition, each distribution switch in each block have 2 uplinks to the 2 core layer switches. In other words, the basic principles need to be applied to the enterprise network. Server farms and mainframes. These are called server blocks and mainframe blocks, respectively. Internet access, e-commerce, or extranet server farms, and firewall farms. These are called an internet block. Remote access. This is called a WAN block. Telephony servers and gateways. This is called a PSTN block. Legacy networks, token ring, FDDI, and so on. This is similar to the WAN block, using a router to provide connectivity to various network media types. Common workgroups of users. End users located in the same building, on the same floor, or in the same area of a floor are called switch blocks. A switch block typically groups access layer switches and the distribution switches to which they connect. Core. If layer 2 switches are used, don't create a spanning tree loop by connecting the 2 core switches. Be sure to identify and configure both primary and secondary root bridge switches for each VLAN. Typically, the root bridge should be placed close to the core layer. If layer 3 switches are used, connect the core switches with multiple links. In a layer 3 core, make use of layer 3 routing protocol to provide redundant routing paths, as possible leverage equal cost multi-pathing ECMP. Each core switch should connect to each distribution switch for full redundancy. If layer 3 is not used in the core or distribution layers, use STP BackboneFast to reduce STP convergence time. Server block. Use redundant uplinks into the distribution or core layer. Utilize STP UplinkFast. Consider using dual network interface cards NC in servers for redundancy. Connect the NCs into different switch cards or modules. Internet block. Use server load balancing to distribute traffic across multiple servers in a server farm. Use firewall load balancing to distribute traffic across multiple firewalls in a firewall farm. Switch blocks. Each access layer switch has dual uplinks to 2 separate distribution switches. Use STP UplinkFast on access layer switches to reduce uplink failover time. Use STP PortFast on access layer ports to reduce startup time for end users. To load balance across the access layer uplinks, adjust the STP parameters so that one access VLAN travels over one uplink while another VLAN travels over the other uplink. Otherwise, adjust the HSRP priorities in a layer 3 distribution so that one distribution switch supports one access VLAN and the other distribution switch supports another VLAN. If layer 3 is used in the distribution layer, use passive interfaces toward the access layer where no other routers reside. Other considerations. For each VLAN, configure an STP root bridge and a secondary root bridge as close to the core layer as possible. Broadcast domains. Limit the size of broadcast domains by controlling the size of LANs. It is permissible to extend VLANs anywhere in the network, but broadcast traffic will follow it. Consider using broadcast suppression on switch ports. VLAN trunking protocol VTP. VTP transparent mode is recommended as the best practice instead of VTP client server modes. Use VTP manual pruning specific VLANs to be transported on trunks. This reduces the unnecessary broadcast traffic on the trunks. Scaling trunks. Bundle multiple trunk links together into an EtherChannel. 4. Fault tolerance. Divide the EtherChannel across switch modules. Do not configure trunk negotiation. Use the on mode. Redundant switch modules. Consider using redundant supervisors and server farm switches where hosts are single attached. If redundant uplinks are provided at each network layer, 2 physically separate switches will always provide redundancy. Use redundant supervisors in distribution or core layer switches where only single uplinks are available. Use high availability redundancy between supervisors in a chassis. Enable versioning so that the OS can be upgraded without a switch downtime. Port security, authentication. You can control the end-user MAC address or the number of users connected to an access layer switch port with port security. Authenticate users at the access layer switch ports. 802.1 Export authentication describes how to configure a port to require a login or certificate for user authentication before granting access to the network. Control access to VLANs with VLAN ACLs. Dynamic ARP inspection is a security feature that validates ARP packets in a network. DHCP Snooping provides the security against the denial of service DOS attacks. IP Source Guard prevents IP spoofing by allowing only the IP addresses that are obtained through DHCP snooping on a particular port. In-station discovery. LLDP is a neighbor discovery protocol that is used for network devices to support non-Cisco devices and to allow for interoperability between other devices. The switch supports the IEEE 802.1ab. LLDP-MED for media endpoint devices. LLDP-MED is an extension to LLDP that operates between endpoint devices, such as IP phones, and network devices, such as switches. CDP is a device discovery protocol that runs over Layer 2, the data link layer, on all Cisco manufactured devices, routers, bridges, access servers, and switches.